Hello, dear students. Today we are going to speak about chapter 4, that is about elements, atoms, and ions. As now there are 118 known chemical elements. These elements are organized in the periodic table. We are going to speak about the periodic table later. The most abundant element in the universe is hydrogen. It makes about 75% of all normal matter. In chemistry, an element is a pure substance that cannot be broken down into simpler substances by chemical means. Each element is defined by the number of protons. Then, the number of protons of carbon is 6. This is what we call atomic number. Also, you can have in the information the symbol of the element, the name of the element, and the atomic mass. We're going to speak about the atomic mass later, but by now I can tell you that it's a combination of the mass of the element that is mainly in the nucleus. The concept of atoms was first proposed by an ancient Greek philosopher, Democritus, around the 5th century BCE. He introduced the idea that all matter is composed of tiny indivisible particles called atomos, meaning that they cannot be divided in Greek. But by that time, there was another um, philosopher that his name was Aristotle, and he did not support the concept of atoms as Democritus proposed. Instead, he believed that all matter was composed of four elements: earth, air, fire, and water. His influence was so significant that his ideas dominated scientific thought for nearly 2,000 years until Dalton atomic model in the 19th century. He postulated that all matter is composed of atoms, they cannot be divided, the atoms of a given elements are identical, atoms of different elements differ in size, mass, and other properties. Atoms combine in simple whole numbers ratios, and also chemical reactions involve the rearrangement of atoms. And he considered that atoms are neither created nor destroyed in these reactions. John Dalton proposed his atomic model in the 18th century. For example, he says that for the same element, the atoms are the same, but they differ from the other atoms. Here you have examples of copper atoms, carbon atoms, and helium atoms. He also said that they combine in simple ratios. But what happened that, for example, nitrogen and oxygen can be combined in different ratios. For example, nitrous gas is 1 to 1. Nitrous acid is 2 to 1, and nitric acid is 1 to 2. As you can see here, for example, the law of conservation of mass is considered in the chemical reactions. For example, you have 16 units plus 2 in the reactants, and the products are the same mass, 18 mass units. The combination of oxygen and 2 hydrogen. And also, he said that the, the atoms combine in constant proportions. Here you have, for example, oxygen. One atom of oxygen combines with 2 of hydrogen. But also, he observed the law of multiple proportions, that sometimes one atom combines with other in different ratios. This is the case of carbon plus oxygen that can produce carbon monoxide or carbon dioxide. His postulation that atom is indivisible and has since been proven incorrect, because nowadays we know that an atom has different particles inside of it. He spoke about that all the elements are the same. However, we have seen discovered an element that can exist in different forms. That's what we call isotopes. The difference between two isotopes of oxygen uh, are in the number of neutrons. For example, this isotope of oxygen has 8 neutrons, while this one has 10 neutrons. But as you can see, the number of protons and electrons are the same. The difference between two isotopes of the same element is in the number of neutrons. But also, the same element can be presented in different uh, forms that we call allotropes. For example, carbon can be diamond or can be graphite according with the structure or the order of the atoms in the space. The first particle, subatomic particle that was discovered was the electron. Thomson experiments involved passing an electric current through gases at low pressure, which produce a stream of particles. But this stream can be deflected by electric and magnetic fields, indicating that they were charged. His findings led to the realization that electrons are fundamental components of the atoms. Now we know that inside of the atoms we have particles. Thomson proposed a model for the atoms. He used the form of the plum pudding, and he says that the electrons negative charged were distributed into a mass that was positive. This is the model that he proposed in 1904. But Rutherford, using the gold foils experiment, he passes radioactive particles through a gold foil. And he observed that not all the particles went through the foil. Most of the particles go through, but some particles were deflected and some travels back, as you can see here. Then, uh, according with this, as most of the alpha particle travel through the foil, he said that the atom is mostly empty space. As some particles are deflected, he said that the nucleus is positively charged as the alpha particles. And also, he accepts that some alpha particles travels back, and he says that the nucleus carries most of the atom's mass. According with this, he proposed a different model from Thomson. Then Rutherford proposed that the electrons were in an empty space. Most of the atom was empty space where the electrons are. And the nucleus is in the center and is small in comparison with the atom at all. The atomic planetary model was proposed by Rutherford. He compares the atom with the model of the solar system. As you can see here is the sun, and around the sun we have the planets. In same way, he said that the nucleus was in the center and the atom and the electrons were spinning around this nucleus in a similar way as the planets are going around the sun. That's why his model was known as atomic planetary model. But how can you have protons so close together if they are positive? How is possible that they don't repel each other? That's why the neutrons were discovered, and as they are neutral, it separates one proton from other, and this way they get nuclear stability. Here you can see in this table the different subatomic particles. The charge, the proton is positive, and the mass is considered one atomic mass unit and is located in the nucleus. The neutron that has no charge at all is neutral. The mass is similar to the proton, a little bigger than this, but are very, very similar, and is located in the nucleus. The electrons are surrounding the nucleus in orbitals, and the charge is -1. And the mass is almost zero if we compare with the mass of the proton and the neutron. After the planetary model proposed by Rutherford, the next significant development in atomic theory was made by Bohr. Let's see what is the model of Bohr. He used quantized orbitals. Bohr suggested that the electrons are traveling in quantized orbits that are around the nucleus. That way you have a level 1, level 2, level 3, level 4, And in these orbits, the atoms can be, they can absorb energy and go from a base level to a higher level, absorbing energy. But immediately they return to the basic level, um, um, emitting energy. The stability of the orbit is because the electrons in these quantized orbits do not radiate energy. What is the meaning? Because during that time, many people say, well, if the electron is moving around the nucleus, is losing energy in this movement, and then it's supposed that at certain time will jump into the nucleus, but it doesn't happen. The atom is uh, stable. How can we explain that? Because the electrons do not radiate energy while they are spinning around the nucleus. Look, if the electrons according with the planetary model, the movement of the electron will conduct the electron to jump into the nucleus by losing energy. But Bohr explained that these orbits are quantized and the atom and the electron do not radiate energy. He explained the, the rates in the emission spectrum of hydrogen. Hydrogen has only one electron. And he explained that these lines correspond with the jump of this electron from one level to another. And he used this formula, the, where R is the Rydberg constant. But what happened? He could not explain the uh, the the structure of the atoms with more than one electron, and then the particle, the quantum mechanics explain this behavior correctly. They say that the particles have a dual behavior. They can be or a particle or they can be a wave. Also we have seen that the probability distributions are not exactly fixed orbits around the nucleus. They are in a region that is most probably to find the electron. Also, we have the Heisenberg uncertainty principle. This principle states that it is impossible to know both exact position and momentum of the electron. The Redinger uh, equation is a mathematical framework predicting the behavior of the electrons in atoms. And the principle of exclusion of Pauli states that two atoms cannot be the same set or cannot have the same set of quantum numbers. They differ at least in the spin quantum number. What is the spin quantum number? Is that two electrons in the same orbit one is spinning to the right and the other to the left. So they differ in the quantum number, in the spin quantum number in plus one, one and 1 over 2 and negative 1 over 2. This is the Pauli exclusion principle. Well, what is the rule writing formula? First of all, we have the symbols of the elements, and we write subscripts that represent the number of atoms of each element. In this case, we don't write the number 1, but we consider that is a 1 here. Then it is 1 atom of sulfur per 3 atoms of oxygen. This is a formula of a compound. Dmitry Mendeleev made or proposed in 1869 the the periodic table. He considers that the atoms can be ordered by the atomic mass. Then, as you can see, ordering the elements and taking into account that after certain period, the, the properties of the elements are similar to the first ones. For example, lithium, sodium, potassium, copper have similar properties, then they put them in a column. And as you can see in this row, the properties are increasing. Well, the atomic mass is increasing, and then he ordered the elements taking into account this property. This was very important because the periodic law that was formulated states that the properties of elements are periodic, and they are in function of the atomic masses. Also, he proposed groups that are the columns and periods that are the rows. He predicted the presence of some elements before they were discovered, and that's why he left in blank some spaces, because he said that between calcium and titanium, for example, there was another element. These elements were discovered later, and they were located in the right place. And also, it's important that using the periodic table, he corrected the atomic mass that was um, um, determined experimentally, but with some errors. The modern periodic table is an organized arrangement of the 118 known atoms. The atomic number is what we take into account in order to give this order. Then the increasing order of the atomic number is what we use in order to rearrange all the atoms. The groups are the columns the same way, and the periods are the rows. As you can see, we have 18 groups and 7 periods. The elements can be divided into the block S, the block P, the block T, and the block F, according with the electron configuration of the elements. We are going to study this in other chapter. Also, we can divide the elements into metals and non-metals. And in between of this zigzag line, we have the metalloids. The metalloids are elements that have some metallic and some non-metallic properties. For example, the metals are efficient conducting the heat and the electricity. They present malleability. What does it mean? That they can be hammered into thin sheets. And they present ductility. What is that? What does it mean? That we can make wires from them. Another important characteristic of the metal is that they present lustrous appearance. Sorry. So the non-metals are to the right, the metals are to the left. Here we can see the non-metals are different from the metals. They can be gases, liquids, solids at room temperature. They don't conduct electricity and so on. Most of the non-metals are to the left, of the metals are to the left and the non-metals are to the right, except hydrogen that is located here because it has only one electron, while the metalloids are in between. This zigzag line divides the metals from the non-metals. The natural states of the elements, well, most of the elements are quite reactive. For example, sodium, in presence of water, is very reactive, produce light and heat. And there are some elements that are not reactive, sorry. They are the noble metals like gold, platinum, and silver, and the noble gases that are in group 8. Helium, neon, argon, krypton, xenon. Some molecules are diatomic. For example, nitrogen is always diatomic. Oxygen is also diatomic. The ions are atoms that have lost or gained electrons. For example, magnesium loses 2 electrons and became a cation. A cation is positive charged because the cation loses 2 electrons or 1 electron. In the case of the anions are negative charged, they gain electrons. This is the case of chlorine. Chlorine, when it is an anion, the name is chloride. We change the ending by "ite," while the cations has the same name as the atom. The most characteristic charges for the for the ions, sorry, if they come from the group 1A alkali metals, the charge is positive 1 because they lose 1 electron. The alkaline earth metals are in 2A and the charge is 2 positive. The halogens in 7A is -1 and the noble gases 0 because they are inert. They don't react. Here in this table you can see the most characteristic charges in some of the groups in the periodic table. You can stop the video and take note of this. Well, let's go into the information that we can get from the periodic table. We have the symbol of the element, the name, the atomic mass, and the atomic number. Remember that the atomic number is the number of protons, and the atomic mass is the sum of protons and neutrons that are located in the nucleus. The ionic compounds are made of ions. A cation and an ion join together and they make generally solid compounds. They have high melting points. They conduct electricity if melted or dissolved in water, but not in the solid state. Ionic compounds are electrically neutral because they have the same negative number of negative charges than number of positive charges. So the sum of anions and cations charges is 0. Here you have a formula. For example, magnesium have two positive charge, two positive, and chloride has -1. Then you need two negative charges, two anions of chloride for one cation of magnesium. That's why the formula is MgCl2. Well, this is the information that we wanted to share with you in this chapter. I hope that you have the information and see you later.